Hello everyone, I am Rohit Rana and I am currently in my final year.
Okay.
And sir, I have recently cracked SDE internship offer from Amazon.
Okay. And is it on campus or off campus, Rohit Rana?
So it was off-campus opportunity.
Okay. Okay. Hello all, with the name of God Ram Ram. In today's session, we are going to solve the recent DSA interview problem from NVIDIA. They offer a CTC of 68.5 lakhs, and the problems they asked are very, very interesting. This particular problem, which we are going to solve today, guys, it is based on dynamic programming. So, in most cases, what happens is that people study dynamic programming from standard tutorials and standard sheets, okay? And then they get stuck on the recursion part and the memoization part. They never figure out that the real thing in dynamic programming is actually being able to realize that is DP needed or not. Okay. And if DP is needed, what should be the transition formulas and what should be the states which we need to make? These two things are the most core important things. If you know how to create the transition formula and if you know which states you need to create for the given problem, then DP is done for you. You are a master at DP. But people keep on getting stuck in recursion and memoization part. That's why, guys, I have created these free dynamic programming tutorials for you. You guys can head over to this link with acqn.in. Like many of my past successful students who have cracked Google, Microsoft, many of them have used this free course. Okay, then they eventually did the main course also. You guys need to scroll below and you can see dynamic programming session 1, session 2, session 3. Please watch these videos so that you understand the actual essence of dynamic programming and you understand how to think, analyze, and how to come up with the states and how to come up with the transition formulas, because those things are important. If you know how to do that, then doing bottom up DP or applying recursion memoization is not difficult. So please do this. Whoever is watching this video, I will assume that you have watched these dynamic programming videos of AdCoder, PayPal OA and all this from my course already. Okay, the link is publicly available, you guys can check it out. Okay, so this problem is that we are given an initial integer a equal to 1. We are also given b queries, guys, okay? And we have to do the queries from up to down. We can skip some queries if we want. So the options will be like this: either add x or subtract a number x or multiply some number x or divide your given number by x, okay? So basically we will be having queries of this nature. Now let me show you via an example. Let's say our input is plus 2 plus 3 minus 1 multiplied by 5. Okay, so let me show it to you. Plus 2 plus 2 then plus 3 minus 1 and multiply by 5. Okay, plus 2 plus 3 plus 2 plus 3 minus 1 and multiply by 5. So lovely people, in this particular case, if you are going from up to down, let's say you start doing the operations. Initial number is 1, so 1 plus 2 is 3. So here it becomes 3. Then 3 plus 3 is 6. Then 6 minus 1 is 5. Then 5 into 5 is 25. So 25 is the final answer if you do all the operations from top to bottom. But guys, they are saying that you're allowed to skip some operations to get a maximum answer. So you know what? You can select this, and you can skip the minus 1 operation, and then your answer will be maximized. So initially number was 1, so 1 plus 2, 3. 3 plus 3, 6. Minus 1 skipped, you don't do this option, then direct 6 multiplied by 5, 30. 30 is the maximum answer you get. Maximum answer you get if you are able to do the operations optimally from top to bottom. Okay. The whole question is around the premise to figure out that which operations should we do to maximize our initial integer 1. A general greedy idea which might come to your mind is that only do the operations which are plus x or multiplication of x. Okay, x is always a positive number, but only do plus x operations or multiply x operations. Never do minus x. Minus x will generally reduce your number. Never do divide by x. That will also reduce your number, right? So you can just skip those options. So you take this, and you skip this, and the final product is maximum. But this greedy algorithm does not work in all the cases. Let me show you the. See, this is a hard unseen DSA problem. If you do standard sheets and standard stuff, you will not be able to solve problems like these. Because this is 2026 AI era and companies are testing candidates on their thinking skills. So you need to practice hard DSA problems and new DSA problems to challenge your mind, because companies are wanting these things only. They have stopped asking the standard easy DSA problems. Okay. Now, listen to me carefully, very, very carefully. In every ingoing and outgoing breath, you have to take the name of God Ram Ram like this. So you can reach moksha in your life. More details about it you will be finding in the YouTube description. So make sure you go through it because you need to reach moksha. Okay, that's the ultimate aim of life. Because after a few years you will die. Then what? Right? Think about that. Anyways, going back to the question, I will like try to show you another example where this thing does not work out. It is plus 2 minus 10 and okay, plus 2 then minus 10 and multiply by 5. Now, if you only do the positive operations, you have 1, right? So you will do this operation, negative operation you will not do. N means multiply by minus 1 you will not do. And multiply by 5. So what will happen? 1 plus 2 is what? It will give you 3. Then directly 3 multiplied by 5, you will get 15. 15 is the answer. But no, just doing the greedy algorithm is not correct here. You cannot do this. Why? 15 is not the maximum answer you can get after doing the queries optimally. The correct answer is select all the options here. Why? 1 plus 2 gives you what? 3. 3 minus 10 gives you minus 7. Minus 7 negate it. Multiply by n means multiply by minus 1. Okay. Minus 7 into minus 1 is plus 7. 7 5s are 35. Earlier you were getting answer as 15. Now by doing these negative operations, it's giving a better answer. Wow. It makes you think, right? It makes you think, right? Yeah. So really interesting problem. 35 is the answer in this case. Okay. Like I by mistake got 40. It's 35. Okay. So, it was a plus 3, then minus 10, minus 7, minus 7, 5, 35. Okay. 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 So, guys, in our dynamic programming methods, what we generally do is that let's say these operations are given to you plus x, minus x, multiply by x, and like these operations are given to you. And let's say this is the ith operation. So, generally, what we do is that we declare an empty dynamic programming array where it starts from, let's say, index 1 and then I, right? dp of I generally means this green part. The meaning of this thing is that the best answer you could find if you only did the options optimally from 1 to I. Okay, dpi means you are only allowed to do the operations in the range 1 to I. Which operations do you do from 1 to I? That's totally up to you, but you have to do it in this order from 1 till I, skip some, accept some, and get the maximum answer. But this dp state will not work here. See, necessity is the mother of invention. Okay. Similarly, in dynamic programming here, max DP state is not enough to work out. We need something extra. Why? I will show you in a second. What we need is that, see, if you were doing standard questions, the logic would be very standard and you would reach the solution easily. But this problem is giving you 68.5 lakhs CTC, right? So they want you to challenge. They are challenging you. So the challenge is pretty simple. You should just check the values are oscillating. Values are oscillating. So if you observe a little bit, you will see that the values are actually oscillating. So let's take plus 2, then minus 10, minus 20, then take n, then take 20, then take 30, then take n. Let's say there are many operations like this, right? If you try to calculate the values, what is happening? Max till here is 2. And what would be the minimum till here? You could just skip this option and this would be 0, right? What would be the max till here? You would skip the minus 10 and it would be 2. What would be the minimum till here? It would be just minus 10, right? Yeah. I hope the same was the answer for that case also. Okay, guys, I did a little bit of mistake. Yeah, sorry. The best answer in the previous test case would be that you have a 1 initially, right? So don't do the plus 2 operation. Directly do 1 minus 10, which is minus 9. Then minus 9, you negate it. Minus 9 into minus 1, minus 45. Like minus 9 into minus 1 plus 45. So you get 45 as the answer. So sorry you had to ignore the first operation. So I'm writing here 45 as the answer, okay? Like, yeah, humans do mistakes, okay? So here also, see, I'm just keeping the track of the max answer and the min answer. You might think, why am I keeping the track of min answer? I will tell you in some time. Max till here can be 2, max till here can be minus 10. If you reach till here, what can be the max and what can be the min? We just need to, think about it. So let's think. Okay. I understand what's happening. The max you can get after the first three operations, if done optimally, it will be 2. And the min which you can get is minus 30, right? Okay. Now comes the negation operation. What is the maximum you can get after negation operation? Can you see? The value which was the most negative, if you multiply it by minus 1, it will turn into the maximum value. Oh my god. And the value which was maximum, like the maximum positivity was what? 2. The maximum positive value you could get was what? 2. If you multiplied by minus 1, then you get minus 2 here. You get what? You get minus 2 here, right? But you can choose to skip, and then the minus 30 from up will remain like this. So these are the three options you get at n. You can either reach 30, you can either reach minus 2, or you can do nothing and be minus 30. So minimum achieved after n is minus 30 and maximum achieved after n is plus 30. So guys, this is the visualization I want to tell you. If this is the max value and this is the min value, what is happening is that values are, or things are happening like this. Whenever there is an n, the max value automatically becomes the mean value, and when n comes again, the mean value has the potential to become maximum value. Similarly, the minimum value can become maximum value whenever n appears. Then the maximum value can become minimum value whenever n appears. Whenever n appears, the n is the game changer in the problem. Earlier, whatever was the minimum achievable task, now it has been converted to the maximum. And earlier, whatever was the maximum is now becoming a viable candidate for the minimum. So guys, values are oscillating. It means you only need to keep track of two things, which is dp max of I, the maximum value you can get by doing the operations optimally from 1 to I, and dp min of I. If we are able to calculate both of these states till the end, then job is done, done. Final answer will be dp max of n. Why? Dp max of n means if you do all the operations from 1 to n in the best way, what is the maximum output you can get after the n operations? If done optimally, guys, if done optimally. Guys, this oscillating logic is very important, huh? Just because this oscillation is happening, that's why we are only keeping track of max and min. Luckily, we are not having to keep the track of the middle values, and that's making the problem really easy for us. Okay, doable for us actually. Okay, so let's think now. What can we do? What will be the formulas? Let's say this is an array, a big array. You know, when you used to learn physics, that teacher used to say that there is a big cylinder, assume an infinite cylinder, small part dx, and then they used to do integration, differentiation, dx by dt, and we used to come up with some theorem or some proof or some derivation. Same thing here. When we are trying to calculate dpi, not same, similar. We want to calculate dp of I. dp of I max. Okay. So dp of I max. So let me write here dp max of I. Okay. So if there are many operations here, okay, let me just show them to you like this. So many options are there, right? So let's say at ith operation is plus x. So what can be dp max of I? The first option is you ignore, don't do this at all. So if you don't do this at all, so whatever is the best answer you got till I minus 1 will be the answer, right? Because you're not doing the ith operation. So if you don't do the ith operation, and guys, there is one more hint. Divide operation is actually not needed, but you can analyze it and write in the comments why. Because divide does not help you with the extreme negativity and positivity, but it might be required. But our dynamic programming will handle everything. dp max of I, if the ith operation was plus x, you can just ignore the ith operation, and the answer will be dp max I minus 1. But what if you decide to go ahead with the ith option? Plus x, right? So whatever best output you got till I minus 1, plus x you will do to it, right? X is always a positive number. Plus x plus dp max I minus 1. These are called hard and interesting dynamic programming problems. So dp max I formula has been calculated if this is plus x. Guys, similar will be the formula if it was, let's say, minus x, okay? Or let's say it was divide by x, okay? Like this is modulo x, I'm talking about divide x, okay? Okay, so these things you guys do understand, right? You do understand, right? So I'm showing you the formulas also. dp max I is nothing but the maximum energy you're getting by doing some of the first operations. Minimum energy you're getting by doing some of the first operations. dp max I for plus, you can see for multiply, for minus. The game changer is n. How would you calculate dp max I? Once this is done, we will calculate dp min I also. What if instead of plus x, this operation was actually n, then what would you do? Okay, so let's try to think about it. If it was n, first operation is you do nothing, that is what dp max, like you ignore the ith operation, so dp max I minus 1. Second option is also pretty simple. That is that you actually negate whatever maximum value you got from here. It is not useful, but you can do that. Minus 1 into, you just do what they said. Like, okay, you got the best value dp max I minus 1 till here, do minus 1 of the negation, okay? But guys, the third option is the game changer. What about the most minimum value which you can get from here? The most minimum value which you can get from here, if you multiply that minimum by minus 1, there are higher chances of success. Why? For example, if this was your I minus 1, what was the most minimum value you could get? Minus 30. But if you multiply minus 30 by minus 1 at this ith operation n, it becomes 30, which is the maximum. So another option is minus 1 multiplied by the minimum value which you can get by doing options optimally from 1 to I minus 1. Minus 1 multiplied by dp of min I minus 1. So it means that is why you need to calculate dp min also from 1 to I minus 1 as you are calculating dp max. Both of them needs to be calculated at the same time in the for loop. Okay, simultaneously. So guys, that's it, and the problem gets solved in off n time, right? And yeah, you get a 68.5 lakh CTC also. Guys, I give free DSA live training on Saturday, Sunday for all the recent companies, OAs and interviews. So the WhatsApp group is in the description. Make sure you join it. Also, I give lots of guidance on this channel as well. Okay, because people really are seeking for lots of guidance and help as per the trends of the DSA questions asked in the online assessments and interviews by different companies in 2026. So you can like, share, and subscribe if you want to make your journey smoother. So guys, lovely people, listen to me. Like you can see the formulas. dp1 is dp max of I, dp2 is dp min of I. You can see for the plus operation, it's just simple. Either you do nothing or you just do what is said, and that's it. Clear? I am considering the minimum options also plus C, just to make the, see, you can add extra things also in your formula. This is a nice thing about dynamic programming. Whenever you write now that dp of I is max of, let's say 2 values, you can write it as max of 3 values also. In case you are not sure whether that third value, let's say this is x1, x2, x3. You know that x3 will always be less than x1 and x2, okay? Then there is no need of writing x3. But in dynamic programming, you can write that option also. You don't need to worry, max option will get the best. So here you can see that for dp max of I, only dp max I minus 1 plus E and dp max I minus 1 was enough. But then also I've written, what if I add a positive number to the minimum dp of till previous? This is not never going to compete with these two, but still I've written. All these are nice. The division is also nice. But guys, in division, you need to be careful. You can only divide if the output is divisible, okay? So, like in this code, we need to make a fix, okay? We need to check if the output is divisible or not. Or, yeah, so I have not written it. I will update the code here, okay? Anyways, going below, guys, see, for if the negation operation is there, minus 1, okay, or minus 1 of previous, or do nothing. Basically, minus 1 if dp for max, minus 1 of dp mean, and these both are enough. This state was never needed, but I just wrote it for the fun of it. For dp mean, minus 1 of the maximum dp till previous, dp1 is needed, and dp2 I minus 1, whatever is the answer to the is needed. Whatever was the maximum till previous multiplied by minus 1, then it has the probability of being the minimum. But dp2i, never you need to write it as minus 1 of dp2i minus 1. Nah. Okay? Because dp2i minus 1 already has a very higher probability of being negative. Okay? Let's say dp2i was coming as 2. It would never happen, but let's say, okay, it would never happen because that basically means minimum. So initially it is 1. Right? Initially it is 1. So your dp2 of I would at least remain 1, I think. Okay, in some of the cases, maybe I forgot to show you the guys those things. Maybe. Okay, no problem. Guys, in this case, na, I like while teaching you this case, I consider the initial value as 0, but in reality, the initial value is 1. So in these cases, the minimum will be like initiated with 1. Okay, so minimum will always be 1 or less than that. It can never be more than that because you can choose to ignore as many options you want, right? And you can just do the divide, and then I'm just telling you a greedy way to maintain one always to maintain the minimum always 1 or below 1. Either you do subtract, or you do just do divide whenever it is divisible, and that's all good going. I hope you can understand these many variations. I did 2 mistakes. One is that in this case I had to explain you that things are starting from 1. So 1 plus 2, here it would be 3 and here it would be 1, but it does not matter, right? तुम initial value को 1 लो या 0 लो, logic वही रहता है. Clear? In some, like there is a very nice code forces problem also similar to this. So like the intrinsic things going on in both of them are same. So so these logics are very important, and sometimes you should focus on the initial values as well. But for this question, these things are enough. In this code, everything is all right. I need to update a case here. Okay, I will update that and I will add it in the documents. Thank you guys for your time. Hope you guys learned a lot. Take care. Good night. Love you all. Ram ram. Ram ram.